Hello guys, KNOCKCAT this side. So the problem we are going to solve today is zigzag traversal. This is a very famous interview problem. So it says given a binary tree with n nodes and we have to find the zigzag level order traversal of the binary tree. So zigzag level order and most of you, if you know the level order traversal, you have solved this problem easily. But if you didn't able to think of the solution, that means you don't know the level order traversal. So we will have a discussion about this whole this topic. So this is an algorithm which is done using a BFS, and we say it as a breadth first search or a level order traversal in a binary tree. So let's look to the very first example, and so let's come to the whiteboard. So here, this is the same tree I have drawn here that was given in the example. So let's say the output demand us to print this binary tree. If you have observed this, the starting node is fine. The next level was reversed 3 2, and then the another level is again 4 5 6 7. So first of all, what is why I said this as level? Because we have to perform a level order traversal, and level order traversal is performed using an algorithm known as BFS. And what we have in a BFS, let's say I have a queue. So starting at the beginning, I tend to push my first node in my queue. This is one. Okay. Then I look for, so this is my first level. I know this is my first level. So now what I do, I know the count of my nodes, which are the part of the current level is one. So my current level node size is one. Let's have a size variable name as one. So I know since I have one node, that means this is my current level, and this node, using this node, I can actually get what are the nodes at next level. What does that mean? I'm at one. Through one, I can know what are the children of one. So what we do? So since we have one, and let's say the problem was given as we just need to print a level out traversal, and this is the problem that has come few days back on GFG also. So if I had to print the level out traversal, it is simply 1, 2, 3, 4, 5, 6, 7. So let's look how we firstly achieve this part of the problem. So I know what. So what we do? Okay. So while pushing 2 and 3, because I know one left is 2 and one right is 3, so I would say, okay, if left exists, if we have left, so what? Add the left part in my queue. So I will say, okay, queue dot push. Let's say this was my current node, and I will say currents left. Okay. So firstly, while I will pop this, I will add this to my answer. Let's say I have already added 1. Now I will pop this since my current hold 1. My current is equals to 1. We are iterating for size 1 because we know the only node in the queue is till now is 1. So now we'll say, do current left exist? This is current left, yes, 2 exists. So I will add 2 into my queue. I will say if my current right exists, current right. So yes, 3 exists. I will add 3 to my queue. And since 1, we have to iterate for size 1, and at that point of time, at the previous level, we have only 1. So the job is done. Let me erase all this. So at this level, we have already iterated our first level, and now we have nodes 2 and 3 with us. So the size of them is 2. Okay, size is 2. Now again, size is 2. That means startingly I will pop my queues front. Okay, queue is actually FIFO, first in first out. That means the node which we added at first, that will pop first. So 2 was, firstly we push 1, then we push 2. So 2 is the next node which was pushed, so it will be popped first. So now my current contains 2, and current will ask, do my left or right exist? And its left and right exist. So current will actually push 4 and 5 if they exist. In this case, it exists. So 4, 5 in my queue. So this iteration is over. At the next iteration, this become 1. So for this iteration, my current is now become 3, 3. And 3 will again say, do my left and right exist. So in this case, again left and right exist. So I'm writing 5. Let me erase this C4. So I'm writing 6 and 7. So 6 and 7 are also in my queue. And since now it's become 0, and since it has become 0, we know we have iterated this previous level also, this current level also. Now we have iterated this also. So while I have popped this, I have also added 2 and 3 to my answer. Now, when I came to 4, I will pop this and I will add to my answer. I will say, 4, do your left exist? It don't exist. So we will not push anything in our queue. It right exists? No, it don't exist. So for this, I forget that I need to maintain size, and size was 4. Okay. So now, and my current was also, it at this point, my current was also 4. For 4, none of them exist. So at the next, this will become 3. And the next node I have on my queue is 5. I will pop this. I will add to my answer. 5 is also added. I will ask 5, do your left or right exist? They don't exist. So that means we will not push anything. So now, next time, this will become 2. And if I get to 2, we have 6 in our queue. 6, I will put 6 in my answer. And then 6 say, do my left or right exist? They don't exist at all. They don't exist. So for 6, left, right don't exist. That means we will not push anything in our queue. Okay, job for 6 also done. This will now become 1. We have 7. For 7, the same thing. None of their parent exist. I will put 7 in my answer and this will become 0. 7 will also pop from my queue. My queue became empty. So we have come out of this and the answer we have got, this is a level order traversal. Level order traversal. Why we say it's level order traversal? We iterate this level, then this level, then this level. So if you get to see, at first we have 1. Then we have 5, 4, 2, 3, 4, 5. Sorry, 2, 3. Then we have 2, 3. And after that we have 4, 5, 6, 7. So we have 1, 2, and 3 level. 1, 2, and 3 level. Okay. Now, if you get to know what we done actually, what we done, now you get to know. So what I was doing, while I was popping from it, I tend to put them in all vector. What if I have a level vector? Let's say I have a level vector. Instead of pushing into my answer variable, I will push into my level. So at the current level, I would have 1 in my level. Okay. In the next level, when I have 2, 3, my level will contain 2 and 3. And the third case, when I have 4, 5, 6, and 7, my level would be containing 4, 5, 6, 7. This time I'm not pushing in this. While I was iterating my size 1 till my size have the nodes, like first we iterate for size because we have 1 node, then we have 2 because this would have popped out, and then we have 4. So we can see earlier we have size 1, so we have 1 node, then we have size 2, so we have 2 nodes, and then we have size 4, so we have 4 nodes. If we can clearly see, let's say I have a variable name as okay, okay, sorry, I have a variable name as okay. So what will I say? If my okay, and let's say my okay is initially set to 0. Let me erase all these because space is getting reduced. Okay. So let's say my okay is initially to 0. Can I do something like that? Okay. If my okay is 0, if my okay is 0, then at that point, add 1 as it is to my answer. Next time, okay will become 1. Okay will become 1 because we are at even level. This was 1 level, this was 2 level, this was 3 level. Now I am at even level. So I make okay as 1. So 1 is that I am at even level. So if we see, answer expect us to return 3 and 2. That means reverse. So this is my current level. I will reverse my this vector. I will get 3, 2, and I add 3, 2 here. Next time, my okay will again become 0 because I am again at odd level, that is 3. And we can see 4, 5, 6, 7. 4, 5, 6, 7. And this time, since we are at odd level, so we will not reverse, and I will add this vector as it is, that is 4, 5, 6, 7, and hence we will get answer like 1, 3, 2, 4, 5, 6, 7. I think the there might be some confusion. Let's look at the code, and you will get to understand what I want to actually say. So code I have put here only. Yes, this is. So clearly, I think you can see this. So for the very first time, this is I take a queue. I push root because this we have to 1. We have pushed. Okay. So let me make a queue also here. We have pushed 1 already. So now size. Why size? Because we need to know how many nodes we have at our current level. At current level, we have 1 node. So our for loop will iterate till 1 for one iteration. And on that iteration, I would be appending 2 and 3. So this would be popped and 2 and 3. And while popping, I will also store these elements into a current level vector. Current level. So current level contains 1. Okay, current level. Let's say it is current level. So current level, and since this iteration would be over, so and this is an odd level, so we will do nothing. We will only push 1 to our answer. Next time, 2 and 3 is now in my queue, so my size will become 2. That means my for loop will iterate for 2 iterations, and in those 2 iterations, it will say in this current level, it will actually push 4, 5 first. 2 will pop and 4, 5 will be there. 4, 5. And in the next iteration, 3 will be popped and 6, 7 we have. And now, since this is an odd level, so I will say reverse this part. Reverse my current vector. So we will get 7, 6, 5. Okay, sorry. We don't need to push this. The nodes which we are popping, we have to push that node. So I have pushed 2 first. So 2, then 3. So I have to reverse these 3, 2. So I can now add 3, 2 to my answer. So now 3, 2. 3, 2 would have add 4, 5, 6, 7 to my queue. These are 4 nodes. So this becomes 4 now. And 4. So this will run for 4 iteration. And now the number of nodes which I will pop, my current will now contain 4, 5, 6, and 7. Okay. And since this is odd level, we will just push them as it is 1, 3, 2, 4, 5, 6, 7, and you can clearly see we have got the answer. So the same thing we did here also in the code. I said, okay, while this is a current level vector, this is a current level vector. While I was popping, I am also adding this to my current level vector. So left, right in this for loop, because I was popping the previous level, I am popping these previous level and adding these next new level. And what I did, I said, okay, if it was okay, and simply you get to understand because okay was initially 1. So at 1, I don't need to perform any operation. Next time it will become 0, then it will become 1. So at this time it will become 0, not okay means 0. So at this point, reverse my vector. So it will reverse it, and then I will add answer to it. And this okay XOR 1 is nothing, 1, 0. It will make 1 to 0, 0 to 1. Because first time it was 1, next time I had to make 0. So for next iteration, let's say it was 1. So for next iteration, I had to make it 0. So that I get to figure out which is the odd level, which is the even level. So this is simply I'm reversing. So if we look for the time complexity of this code, this would be order of n. And by order of n, let's say I have a full binary tree, and at every child have two nodes until here. So we have 1e5 nodes. That means log 2 of 1e5 iterations we will do. Log 2 of 1e5 iterations we will do. That would be 16, around 16. Okay, that will be around 16. That means we will iterate for 16. 1, 2, 3, 4, and 16. And at the last level, we would be having 2 raised to the power 16 nodes. That will come around 65,000 something. And so at worst, I am iterating this reverse. I'm reversing. So the maximum I can have at any level is these number of nodes, 65,000 around 300. So this is nothing but order of n only. And since this is only going to iterate for, this is only in the best case I'm saying, this is going to iterate only for 1e5 of log 2 times. So this will give us this log 2 of 1e5 into order of n. So this is order of n only. This is the example when I said this is the full binary tree. Now, why I assume full binary tree? Because I need to tell the time complexity of this reverse function, because this reverse would be order of n. So at the maximum nodes we can have any level is only when we have a full binary tree. So then let's say we have, so that's why all are filled. So this would be the maximum we can get. Now, if we have to say, let's say we have a skewed binary tree, we have the binary tree like this. So this is the naive case. For this also, we will only have order of n iterations. So overall, this would be order of n only. I took this case because I assume what was the complexity of this reverse function. So at worst, the reverse function, if all nodes have full binary tree and all nodes contain nodes at each level, so at worst it would be 2 raised to the power 16 nodes at any level, which is the last level. And so for this last level, the reverse will take order of n. And over this case, these iteration would be log 2 of 1e5. So that would be 16 only. So this would be the time complexity. But overall, let's say we have a skewed binary tree like this. So in that also, we have order of n iterations only. So time complexity for this also boil down to order of n only. And the space complexity is also, let's say, order of 2n, because we have an order of n cube and a vector where we are storing order of n all the elements for this zigzag order traversal. So the this is the code for this. And now, can we eliminate this reverse function? Can we actually eliminate this reverse function? Yes, we can. Let's say this reverse, since we are actually iterating here and after reversing also we are putting it here. So we can do, okay, if this was the case, either putting it into from left to right, put it from right to left. So I can write a for loop here for this case, write a for loop from n minus 1 to 0. But we are doing order of n also here also and here also. So that do not make any difference in this case. Okay. So like if I have to show you the code for that also, the similar first code is this, where we are actually putting this, and this was the thing I was saying, that have an index, because let's say I have this here. If I'm iterating from left to right, then the first index would be this. But if I was iterating from right to left, then the first index I need to be putting was n minus I minus 1. So the same thing I am doing. And over this I am putting, if that was left to right case, I was filling in this order. And if was right to left case, we are filling in this order. So, but still we are having this order of n here and left to right here, because this is also telling first time we are doing from here to here and then from left to right. This is also taking, even if we have just eliminate our one loop, this is the same thing that we are doing earlier, because we are actually putting these nodes here, and this is we need to eliminate. Even though for reverse we are not doing like we are not performing reverse every time, but still for pushing the elements into our main array, we are taking these number of elements time complexity. So how to eliminate that? So this was the very first approach. Here we are doing this. Here we are doing this, and also this. This was common. This is pretty common. We just modify that we don't have to reverse it. Okay. So these are pretty common in both approaches. Now come to this approach. I hope I get to explain you this code. It is just BFS. So for the current, I am putting from left to right, and for that I'm going from right to left. So we are have performed reverse. So now come at how we will be solving, like if we do not have to do in a way, we don't have to reverse and that functionality. So now we will use a DQ. DQ. So a DQ is similar to Q, but in Q, what happened? In Q, we can only pop from front, and we can like FIFO, first in, first out. So we can push in our queue, but we can only pop and we can only pop from the very only first end, and pop we can do from rear end. Okay, rear front. But in DQ, what happens? We can pop as well as push from our front end, and we can push and as well as pop from our rear end. Okay, that means this is a two-sided, double-ended queue having insertion and what we say NQ and DQ from here also, and NQ and DQ from here also. So now how we will do this? Let's take this case. So this is our queue, okay? This is our queue. So at a very first level, this is our, let's say, I gave name as 101, and this is last level 1. Okay. Assuming this is even level, odd level, this is even level, and this is odd level. I think there is no need of worry on this. Okay. So what we say at the very first level, we have 1 in our queue. Front is pointing to here, and there is also pointing to here. And when I add 1 here, I will also put 1 here. Now, since this was the even case, and next time I need 3 2. Next time I need 3 2. So I say, so push 3. I will push my right first, then my left. So let me write here first. If it was at even, I am at even. I will take the element from my front side, and I will push right first, then my left. That is, I am at 1. So I have popped 1. I have popped 1. I will take 3 first, then I will take 2. So my rear will come here. My front is pointing to 3. That's it. Let's erase it. 1, and now we have 3 2. And since we have 3 2, while I was right first, I also add 3 here and 2 also here. Now the interesting is, this time I'm at odd level. This time I'm at odd level. So when I'm at odd level, I will take my cues from back, that is rear side, and I will push left first, then right. That's it. So now 3 2, 3 2. So this is the case. So 2, because we are looking from back side. So when I will looking from back side, what will happen? What will happen? 2 will be popped out, and we are adding left and right, but this will be add in our front side. This we will add. This time we will add at back side, and this time we will add at front side. We are popping from back, adding in front. Popping from front, adding to back. So 2 has been popped out. If I will pop 2, and for this odd case, I will push left first, then right. So what will happen? 4 will come here, so my front will shift to here. Okay. Now, if 5 will come here, my front will again shift to here. So this was the thing, and we match the ball. And my rear will point to 3. My rear will point to 3. And while we did the same thing, I have also added 4 to my answer and 5 to my answer. 5 to my answer. Next time, I will again, yes, I will pop 3. I will pop 3. And when I will pop 3, I will do for left and right. So 6 would come here. 6 will come here. Front will come here. 7. 7 will come here. Front will come here. That's it. Rear pointer would have come here. Front is here. Okay. Erase these. Erase these. And while 6 7 was also here now. 6 7 is also here. These are popped from my queue 3 2. Now we have 7 6 5 4. Again, now I am at this level. We have put in this, and these are in my queue, and I was playing with 3 and 2. So now I'm at even level, and I have these in my. So for even level again, we will push from front. Even level, because I'm at even odd even. Yes, we are at even level. even level, okay, for even level, we will pop from front. That is, I will actually pop out my 7 and pop out my 7, and I will put right first, then my left, right first, then my left. So 15 would come, and that would be on rear side. 15 will come, and I will keep 15 here also, and then 14 will come, and then I will put 14 here also. My rear will come to here, and since we have popped this, my front and rear, my front is now pointing to this part. Okay. Next time, again, I will look for Q's front. It was 6. It is 6. 6 have 13 and 11. 13 and 12 because we are putting right first, then left. 13 here, 12 here. 13 would have come here. 12 would have come here. This would have popped. Front is now pointing to here. I think things are getting clear. Now again, we will put from front. 5 will be popped out. It will keep 11 here, 11 here, 10 here, 10 here. Front will come to here. Rear is coming here. Okay, rear is coming here. Now for 4, again 4, 9 will keep, 8 will keep, front will come here, and 9 and 8, 9 and 8 it is, rear will come. So if we have again the next level, if we have next level, so the next time I would be needing from this side. I would be needing from this side. So that means again this would be an odd case. So for odd case, what we do, we pop from back. We pop from back, and from back it was rear, and then we push 8 left right, 8 left right, and so we get this order only. So this is how we will achieve this. I know this is a bit confusing, but if you do a dry run by yourself, you can clearly see I was also a bit messed up in between, but it was better that we take an example again. Actually, there was a pressure like, because if the video was getting long, less people used to watch it, and that's why in getting things early, we tend to get mistake. So I know the video is getting already long, so I am showing the code from here only. No, if you know the very first part, you are very fine. This is like, you should be know like how to optimize the part. What we did, startingly I pushed. So the same thing that I will not go the code line by line, but just we have a DQ this time. First node I have already put, and okay true, for even odd case. So I put Q in my root. So if it was the case okay, and let's say it was, can I split? Can I split? Can I split? Yes, we split. Oh, why would I have, why I've erased? Yes, that's it. So if it was, startingly it was 1, true case. So if it was even case, we are front, we are doing the same thing. If it was even case, front, I'm making my current as front. Okay. And then we have to push right and left. So if even case I am doing right first and left, right and left, right and left, and we have to push in the back of Q. So Q dot push back, Q dot push back. Similarly, when odd case, else would be an odd case, I am popping from back, and we are adding in left right. So this is the case, else case. We are adding left and right, and in the front of Q, Q dot push front, Q dot push front. So this is only thing. These two cases, this thing you will not get very, like, very simply. You need to dry run, make case by yourself and try run it. This is the case. For even case, we will pop from front. We will push right first and then left, but in Q's backside. In odd case, I will take element from Q's back. I will add into my Q now from left and right, but I will add in the front side of Q. So this is the whole thing. Result, and we are maintaining the result vector at the same. So the overall time complexity of this solution would be, again, we have a DQ, and it would be order of n only. For DQ, push back and push front, the amortized time complexity is order of n, so that is not a concern. Order of n is the space complexity, and plus you can say order of n for the level nodes, for the answer vector, and the time it would again take would be order of n only, and order of n only. And this have, if it was a full binary, then it would have taken log 2, but it can be in a manner skewed. Let's say we have here, That's why it will only traverse like at worst order of n only. Like if nodes are in this queued manner, so order of n time complexity and order of space complexity. For you, if you are a very beginner, for you this code is also going to work fine, and this is very good approach. We just tend to optimize it a bit by saying, okay, we will not do a reverse operation. Either I will do uh, from left to right, so index will be from starting from I, but from right to left we will fill from here. Okay, I will add the whole three codes, and for a better view, like how we tend to achieve things. So this is also easy, but how like those cases, when to take back and all, and these all things are covered here. Try by yourself, try run on one case. I think the video is getting very long, but no worries. I am gonna still gonna upload with that mistake also that we did. Or I should remove that. Okay, we will see what to do. I don't know editing, so I had to put it like that only. So like overall, the time complexity for this case would be nothing, but let's say order of n. For all operators, it is order of n. Okay, not for this one. Order of n for all order of n. Our reverse operations also take order of n. Okay, so you don't worry that reverse is taking more here. So this is, I hope you get to understand this. The video might get long, but if you are coming to the very end, you might get the idea very clear. So thank you and knock at this side.